matter or non-matter. And this capacity sensor is very cost relative to the inductive proximity sensor. That means this one will be more expensive. Okay. In most applications with the metallic target, we will use the inductive sensor. It's more preferable because this is more reliable and more affordable. Normally, we will not use the capacity sensor to detect the metal target, okay? Because if we use a inductive sensor, that will be much cheaper and more efficient. That's why I say from here, you need to consider the material. Here. You need to consider the material of the object that will be measured, okay? If you use a metal object, I have two choices. Either I can use capacitor sensor or inductance sensor. But if you consider the cost, then I will use the inductance sensor because the capacitance is more expensive. Okay, and the capacitor proximity sensor are similar in size, shape, and concept to the inductance proximity sensor. Both capacity and proximity sensor, they look very similar. They just look like this. And then this is the head where we're going to use the sensor. So you need to remember this inductance or capacity sensor is non-contact. Non-contact means you no need to use your product to touch this surface. Okay, you just need to bring close to it. Okay, close to it, this one will detect. The sensor will detect. For example, for the capacity proximity sensor, it consists of a single capacity plate from the object, and which has to be metallic and earth, and like this one. Okay, cohesive cable to touch the object, the capacity sensor, but you just need to bring it closer. Okay, how the working principle of the capacity sensor is they need to have a capacity and we also need to have a level detector, solid state output switching device, and just adjustment potentiometer, just like this one. This is your look AB, or this is your output, and this is your adjustment potentiometer. So you can adjust the value of your capacitance. So the capacitance proximity generate an electrostatic field and react to change its capacitance caused when a target enter the electrostatic field. Okay. When the inactive, as the target approach, a capacitor coupling develop between the target and the capacity prompt. When the capacitance reach a specific threshold, the oscillator is activate trigger and the output circuit to switch the state between on and off. For example, like this. Okay, this is your object. Okay, how close is your targeted object? If the targeted object is very close like this one, then you will have this type of oscillation. And this oscillation is maximum. Then when they have maximum oscillations, then they will send the signal to your microprocessor to tell you something is approaching. Okay, if your distance is too far away, okay, or maybe like this one, then you cannot detect. But if you send you like this one, the oscillation rate will be higher like this. Okay, after that you can not detect anymore. That means this capacitance sensor, they have the range. Okay, for example, 0 to 5 mm or 0 to 3 mm or maybe 0 to 1 centimeter. Other than 1 centimeter, for example, like this one, here maybe 1 centimeter. If other than longer than 1 centimeter, this capacitor cannot detect. That's why when you use a capacitor sensor, you need to justify what is your detect range to suit your application of your project. Or if you want to use the capacitor sensor, make sure you want to place your capacitor sensor very close to this range. Okay, so that you can detect the object when it pass by. So this is the capacitor element. So the capacitor actually is proportional to epsilon r, epsilon 0, and A over D. So A is a fixed because A is the overlap between the two plates. Okay, that means here. And then ER is the relative permittivity, and then epsilon is the permittivity of the free place. Okay, and then D is the distance between the plate. So the ability of the sensor to detect the target determined by the target size, dielectric constant, and also the distance from the sensor. These three, okay, will affect the usage of the sensor. So where the larger the target size, the stronger the capacitor coupling between the prompt and the target, and the material. For example, some of the material, they have a very high dielectric, and some is a very low. And the shorter the distance between the target and the prompt, the stronger the capacitance coupling between the prompt and the target. That means this one. Okay, the closer your target object position to your sensor, the better the higher sensitivity. Okay, the more sensitive. So this is the capacitance sensor. So so guys, maybe we stop here for a while for a break. I think if I keep on continue, now it's almost 3. Yeah.
If break, then
no, cannot break. I think I need to continue because I think the times. I didn't notice. I keep on talking. Nobody stopped me. I even not notice that the time's close to 3.
It's okay.
Because this sensor actually is a very big chapters. Okay, they have a lot of sensor. Okay, maybe we stop here lah. I think no point for me keep on talking. Then you guys cannot digest, absorb. So I need some feedback. So do you guys have any questions?
No from me.
Okay. The next lab we will go for the capacitance sensor, inductance sensor, limit switch, some of the sensor. Okay. Maybe if you have a chance to look at the sensor first, you will have a better understanding how to use the sensor. Actually, the importance of this chapter is I'm not very concerned the working principle of the sensor. Okay, for example, like how we my emphasis are how we going to use the sensor. Okay, how this sensor is being made. All this we will leave it to the scientists or engineers to build it. What my emphasis for this chapter actually is the application. Okay, as you can see here, you need to evaluate the application of how we use the sensor. Okay, the working principle, I'm not too worried about it. Okay, because at the end of the day, you need to at least know a little bit of capacitance sensor. We check the dielectric, and then how this one work only lastly. Okay, but more important is the capacitance sensor is used for is often used for non-metallic material. For example, like I can use my capacitor sensor to detect plastic, to detect wood, to detect glass. Okay, when you bring a glass cup very close to the capacitance sensor, they will detect it. Okay, there is a something approach. This is what I want. Okay, I'm not going to ask you all this because this is very long-winded. All the I'm not going to ask you how this sensor is being made. Okay, so you guys just bear with me because my duty is to transfer the knowledge. Okay, at least you need to know a little bit of how this one, but more importantly, actually it is the target size, dielectric constant, and the distance from the sensor. Okay, this is more important. You need to know. This is the thing you need to know. Okay, this one you just let me explain. If you have the interest, then you can further evaluate it. Okay, guys.
So it's like we need to know a little bit on how that thing works in general.
Yes.
Okay.
Okay, because in general that's enough. Okay.
Okay.
But more what I want is more on this application, how you use. Okay, because okay, next the next week we will go for the displacement. And then start from displacement because the sensor is a very big chapter. They have 106. That's why just now I keep on read very fast. Okay, I managed to go until 46. Okay, I managed to go until where? Not 46. Until here. Okay, so this one, I still have 70 slides to go. Okay, this one actually is take 2 weeks. So I will mark your attendance all present. And I'm also very sorry about this chapter. This chapter actually is a quite boring chapter because a lot of theory. So I only can do it very quick. If you really need to understand more, okay, you are welcome to ask me during the practical section. Okay, or if you know, I will highlight what are the importance that you must know. Okay, for example, just now what I mentioned here, you might know this, the sensor of the capacitance sensor. Okay, and also other sensor. Okay, that's all for today. I'm sorry I forgot to give a break to you guys. So next time, please alert me, because if you ask me keep on talking, then I will keep on talking for non-stop for 2 hours. I can do that because this is my professional. Okay.
Okay.
Okay. Thank you, guys. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, thank you, sir.
Thank you, sir.